Dear students, after studying this module, you shall be able to know about DNA database, ND-NAD, CODIS, database applications for criminal investigations, ethical issues related to DNA database, and India's DNA proposal. First, we will start with the introduction to DNA database. DNA databases are the large collections of DNA sample and identifying profiles. They are used to solve crimes by matching samples from convicted felons to unsolved crimes, exonerate possible suspects, proving innocence of convicted felons. DNA databases were developed to help solve crimes by creating a network for exchange of information among law enforcement agencies. More specifically, DNA databases allow forensic laboratories to compare DNA profiles electronically to identify the perpetrators. The United Kingdom established the world's first national DNA database, the National DNA Database or ND-NAD, in 1995. It demonstrated initial success in solving crimes. 3 years later, the United States introduced its National Combined DNA Index System or CODIS. By the end of 1998, other countries like Austria, Germany, Netherlands, New Zealand and Slovenia have also introduced national DNA databases. The table below describes some national DNA databases: the country, the year of their establishment and the suspect entry criteria, convicted offender entry criteria and the removal criteria from the DNA databases. For the country like United Kingdom, the first year of establishment was 1995. The suspect entry criteria is any recordable offence that leads to imprisonment. Convicted offender entry criteria is entered as suspect, and removal criteria is they are never removed. Then is Austria in 1997. The entry is any recordable offence that leads to imprisonment. Entry as suspect. Only after acquittal the removal is there. Then Netherlands 1997. Entry: no suspects entered except when suspect's DNA is tested for the case. And offence leading to more than 4 years in prison. Removal is after 20 to 30 years after conviction. Germany, it started in the year 1998. Offence leading to more than 1 year in prison. Then after court decision, then removal is after acquittal or 5 to 10 years after conviction is prognosis good. Slovenia 1998. Any recordable offence that leads to imprisonment, entered as suspect, and removal depends on the severity of crimes. United States 1998. No suspects entered under revision, depends on the state law, and again the removal also depends on the state law. Then is Finland 1999. Offence leading to imprisonment of more than 1 year, entered as suspect, only after the acquittal they are removed from the list. Then is Sweden in 2000, then Switzerland 2000 and France 2001. Then we will discuss about the aspects of a national DNA database. Implementing an effective national DNA database is an enormous task. A number of components must be in place before the database can be established and actually be effective. These include: first, a commitment on the part of each state and local government to provide samples for the DNA database, both offender and crime scene samples. Second, a common set of DNA markers or standard core set so that the results can be compared between all samples entered into the database. Third, standard software and computer formats so that data can be transferred between laboratories, and a secure computer network to connect the various sites involved in the database if more than one laboratory is submitting the data. And fourth, quality standards so that everyone can rely on results from each laboratory. The technology of forensic DNA databases basically involves three parts. First, collecting specimens from known criminals or other qualifying individuals as defined by law. Second, analyzing those specimens and placing their DNA profiles in a computer database. And third, subsequently comparing unknown or Q profiles obtained from crime scene evidence with the known or K profiles in the computer database. This last part often requires laboratories to work cases without suspects in order to put the crime scene DNA profiles into the database. A DNA database then enables a massive QK comparison. Using these DNA databases, law enforcement agencies have been successful in identifying suspects in cases that would likely be unsolvable by any other means. Within the United States, all 50 states have enacted legislation to establish a DNA database containing profiles from individuals convicted of specific crimes. The laws vary widely across the states concerning the scope of crimes requiring sample collection for DNA databank entry. Almost all of the states now collect samples from all felons, and a growing fraction are even entering DNA profiles from those arrested of certain violent crimes. The trend toward broader coverage of criminal DNA databases will likely continue as these resources demonstrate their value to the criminal justice system. Now we shall discuss about the UK National Database. First, the brief history. National DNA Database was established in 1995 in England and Wales. Scotland and Northern Ireland have their own databases but also submit their profiles to National DNA Database. Now we will discuss about its management. Three entities handle the management and operation of National DNA Database. A strategic board consists of the Home Office, the Association of Chief Police Officer ACPO, the Association of Police Authorities APA, and a member of the Human Genetics Commission HGC is responsible for oversight. Next is a custodian unit of the Home Office unit is responsible for setting standards of performance for forensic science laboratories to provide DNA profiles to National DNA Database by monitoring participating laboratories and ensuring that profiles are submitted and maintained. Next is the Forensic Science Services FSS carries out day-to-day operations of National DNA Database under contract to the Home Office. The Forensic Science Service is responsible for loading DNA profiles onto the system, conducting searches for matches and reporting the results back to the police. The Forensic Science Service is the largest provider of DNA profiles to National DNA Database. The Forensic Science Service's delivery of National DNA Database contract services is overseen by the custodian unit of the Home Office. Now the index. Two types of samples are stored in the DNA database: crime scene samples and samples taken from the offenders. Now how the entries are made. National DNA Database provides that DNA samples can be taken from an individual arrested and detained in police custody in connection with a recordable offence. Most offences other than traffic offences committed must be recorded in the Police National Computer System as part of an individual's criminal record. Samples can be non-intimate, typically mouth swabs, taken without consent, or intimate samples, blood, taken with consent and known as criminal justice or CJ samples. The National DNA Database contains the world's largest number of DNA profiles in proportion to the population, approximately 5%. As of February 2006, the National DNA Database held approximately 3.4 million offender profiles and 2,90,000 crime scene profiles. Additionally, more than 7,21,495 investigations were aided with National DNA Database. 6 agencies in the United Kingdom are approved to provide DNA profiles from offender and crime scene samples to National DNA Database. They are accredited both by the United Kingdom Accreditation Services and the Custodian Unit of the Home Office. Next, we will be studying about the United States Combined DNA Index System, also known as the CODIS. First, the history. A pilot project started in the United States in 1990. It included only 14 states and local agencies. The Congressional DNA Identification Act of 1994 authorized the Federal Bureau of Investigation, that is the FBI, to establish a national DNA database. By 1997, 13 STR loci were selected as the core loci for the national database, and CODIS was finally formed in 1998. Currently, all 50 states have authorized the collection of samples from convicted felons for DNA databasing. However, state laws vary. All states are required to collect DNA profiles from individuals convicted of felony sex crimes, while others authorize collection for additional types of felonies. Now we will study about its infrastructure. CODIS is a database with 3 hierarchical levels: the local DNA index system, LDIS, the state DNA index system, SDIS, and the national DNA index system, NDIS. The national tier represents the highest level. The DNA profiles from LDIS are loaded to the state level system. NDIS is the central repository of DNA records submitted by the states. Communication is mediated using a secured network with encryption. In this figure, we can see the infrastructure of CODIS. Now, we will discuss about the management. The LDIS is maintained by crime laboratories operated by police departments, sheriff's office, and local agencies. All forensic DNA records originate at the local level and are transmitted to the state and national levels. Each state maintains a system that allows exchanges and comparisons of DNA profiles with other states. Searches of DNA profiles can be conducted at the national level. NDIS is administered by the FBI, and the Bureau provides software installation, user training, and support for all laboratories that participate in CODIS. The quality assurance standards for convicted offender database laboratories was set up by the DNA Advisory Board in the year 1998. Now, the index at all the 3 levels of databases, the data collected in CODIS is separated into 2 indices. First, the forensic index containing DNA profiles obtained from evidence collected at crime scenes, and second, the offender index containing DNA profiles of criminals convicted of sex offences and several other violent crimes. Now, database entries, how they are made into the CODIS. As of April 2007, the NDIS contained more than 4.5 million DNA profiles of convicted felons and 1,70,000 forensic profiles. Although the proportion of the population represented on the database is only approximately 1.5%. The NDIS contains the largest number of DNA profiles in absolute numbers. Each profile stored in CODIS includes additional information including specimen identifiers, the sponsoring laboratory, and provided the sample and the DNA profile of the sample. However, it does not include individual criminal history records, dates of birth, social security numbers, or case related information. Now, what are the DNA markers that are used by CODIS? The CODIS software supports the storage and searching of both restriction fragment length polymorphism, that is RFLP, and PCR based DNA profiles, that is HLA-DQA1, polymarker, and D1S80 and some STRs. Database applications for criminal investigation. The ultimate goal in the database utilization is assistance in solving crimes. A hit is a match made from the information provided only by CODIS. Investigation-aided cases are those assisted by CODIS hits. The number of investigations aided is a useful method for measuring the success of the application of the database. As of April 2007, over 48,500 hits made with CODIS assisted in more than 49,400 investigations. The technological advances and the increase in awareness of the great potential of DNA in solving crimes led to sharp increases in demand for and utilization of databases. More jurisdictions are incorporating more felonies into lists of crimes that require DNA profiles, and some plan to include all felonies in such databases. First is case to offender searches. Matches of forensic and offender profiles can reveal the identities of perpetrators. In 1998, Leon Dundas, a Florida man, was a suspect in a rape case and refused to provide blood sample for DNA testing. A year later, Dundas was killed in a drug deal. The investigators were able to obtain a sample of Dundas' blood from the medical examiner's officer. The DNA profile was compared with the forensic index in CODIS. Surprisingly, investigators found that Dundas' profile matched with the DNA sample found in the rape case and linked him to 3 other unsolved rape cases in Jacksonville and 7 more in Washington, D.C. Without the DNA base, such cases would not have been solved. Second, case-to-case searches. Matches of profiles in the forensic index can link crime scenes and aid in identifying serial offenders. Law enforcement agencies in multiple jurisdictions can coordinate their investigations and share leads. In 1996, 2 young girls were abducted from bus stops in St. Louis. Both girls were raped and DNA samples were collected. Both DNA profiles pointed to same perpetrator. In 1999, the St. Louis police decided to reanalyze the samples using the new STR technology and sent the profiles to the CODIS database. A match was made to a different rape case to which Dominic Moore, the perpetrator, had already confessed, thus identifying him as the perpetrator of the 1996 rapes. Third, familial searches. Familial searching, recently introduced in the United Kingdom, is a new method of applying databases in criminal investigation. Familial searches are conducted only for the most serious offenses and in cases when a DNA profile from a crime scene sample has no match in the database. The technique is based on the assumption that the close relatives share similar DNA profiles. Thus, databases may be used for familial searches. If a perpetrator's close relative has been convicted of a crime and is listed in the database, these familial searches may lead to identification of a perpetrator who is the source of crime scene evidence. The first familial search leading to a successful prosecution was conducted in Surrey. In 2003, a truck driver was killed after a brick was thrown through his windshield from a bridge. The perpetrator's DNA profile was obtained from the brick. A search from the National DNA database revealed no match for the perpetrator. Next, a familial search of the database was conducted. The system identified a close relative that led police to identify the perpetrator, Craig Herman, who was then convicted of manslaughter. Policies on familial searching vary among jurisdictions. Familial searches are rare in the US because of concern about the potent impact on individual privacy rights, particularly the potential for these searches to violate the privacy of unrelated people whose genetic profiles happen to resemble those of individuals included in the DNA databases. Federal privacy laws prohibit the FBI from performing familial searches within its database, although some states have granted authority to perform familial searches. In 2003, a perpetrator's DNA sample left at the scene of a rape and murder committed in 1984 was reanalyzed using forensic DNA techniques. The DNA profile from the scene was compared to the profile of Derry Hunt, who was imprisoned for the crime. The two profiles did not match. The state's database of 40,000 convicted felons was searched and no match was found. The search, however, identified a close relative of the perpetrator. This led the police identify Willard Brown as the perpetrator. Brown was sentenced to life in prison. The DNA evidence exonerated Hunt, who spent 18 years in prison for a crime he did not commit. This case demonstrates that DNA databasing can prove guilt and also exonerate the innocent. Now we'll discuss about the ethical issues related to DNA databases. The use of any DNA database involves the balance of individuals' civil rights and the interests of the criminal justice systems, which may vary from the jurisdiction to jurisdiction. The major ethical issues related to criteria for sample entry and retention are as follows. First, entry criteria. Many countries such as United States do not allow entry of suspects' profiles into DNA database. Other jurisdictions such as the United Kingdom allow DNA samples to be taken from individuals suspected of committing recordable offences that may lead to prison sentences. The entry criteria of convicted offenders vary by jurisdiction. The DNA database system is projected to include the profiles of minor criminals because statistics show that most offenders found guilty of serious crimes were previously convicted for minor crimes. Broadening the size of the database and including samples from more types of crimes could lead to the assumption that the number of crimes solved would also increase. Although more jurisdictions currently enter only serious offenders into databases, it is possible that one day the databases will include many more offenders and suspects as well as the general public. One advantage of including an entire population in the DNA database is the ability to identify missing, kidnapped and abducted individuals in addition to victims of major accidents and mass fatalities. Debates concerning the need to balance the benefits and dangers of developing a broader database will inevitably continue far into the future. Then retention of samples. Austria, Finland, Switzerland and the United Kingdom retain reference that can be retested if new technology becomes available. Conversely, Germany, Netherlands, Norway and Belgium do not allow retention of samples from offenders after DNA profiles are obtained. Considerable debate has surrounded the retention of samples for possible retesting with future technologies. This would allow the retesting of a suspect sample if required or for purposes of updating with additional loci. The suggestion was made to use CODIS to obtain more reliable and useful population statistics based on data from a broader population. However, it can be argued from the opposite perspective that the database could reveal private genetic information that could be then misused. The objection is based on concern for protection of privacy rights. If a sample were made available to an unauthorized person, confidential information could be disclosed. Destroying samples would prevent the use of DNA analysis for the purposes other than the forensic uses. Now we shall discuss about India's DNA proposal. The collection policy is very unclear. When is consent needed? No judicial oversight. It includes a wide or expandable list of crimes and also civil cases, missing persons and their relatives and volunteers. It does include a removals process, but for DNA profiles only relies on court informing the DNA database managers. Samples and other data may be retained. Process may be unreliable. What about the cases that do not go to the court? Unclear what DNA profiling system will be used and whether it has sufficient statistical power, how big will be the DNA database, and the population of India is quite big as compared to US and European Union. Existing labs may carry on without quality assurance. Will corroborating evidence be required in court? Will a confirmatory sample be taken from defendants? Is the proposed system cost effective? What other data will be retained in order to identify an individual when there is a match? Could this be misused, example, to refuse visas, jobs, etc.? How will state level DNA databases be managed and controlled? Will they keep DNA samples indefinitely? Will these be used for controversial research? What is the present situation in states and what is the legal basis for collection, storage and the use of DNA and other data? India is still very unclear about the proposal it is making for DNA databases. Now we will conclude this module with a summary. Most DNA data banks serve important and socially beneficial purposes such as apprehending repeat offenders, identifying human remains and health decisions. Use of DNA can help solve crimes, but putting more people on a database may not help to solve more crimes. DNA databases can breach privacy of citizens. This can be justified during an investigation but not always afterwards. Safeguards and high technical standards are essential to prevent abuses and miscarriages of justice. Thank you.